In this lesson, we're going to use a fourth method for solving quadratic equations. We have used factoring, square root property, and completing the square. Now we're going to use the quadratic formula. Before we actually use the quadratic formula, I want to give you an opportunity to see where the quadratic formula comes from. All right. Let's suppose that we have a quadratic equation in the form ax squared plus bx plus c equals 0. Remember, we said a can't be 0 because then we wouldn't have a squared term. Now, this can be a rather long process, so I'm not going to say every step. You'll probably see it again in college algebra. But what we do is we take this equation. We pretend that A, B, and C are numbers, and we go through the process of completing the square. We divide everything by the coefficient, so we divided by A. We move this C over A, which is the constant term, to the other side. It becomes negative. Here is the little step that is off to the side where we take the coefficient of the x term, we take half of it, we square it, and we get the amount that we're going to add to both sides. You will not be asked to do this. I just thought you might want to see where it comes from. You have to add these two terms together, which means getting a common denominator and so on. You do that, and here it is. Then we rewrite this as factors, a binomial squared. We use the square root property. Then I ask, can you simplify? The answer is yes, you can simplify the denominator. You subtract this term, put them over the same denominator, and then it is important that you have written down the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all of that over 2a. Make sure that's in your notes. All right, let's use the quadratic formula to solve any quadratic. The first thing we have to do is make sure it's in the format ax squared plus bx plus c equals 0. And we need to identify the number in the place of a, the place of b, the place of c. So a is the coefficient of the squared term, so it's an implied 1 m squared. B is the coefficient of the m term, so it's a 10. C is the constant, so it's a positive 21. Now, m is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. M is equal to, it says negative b, it means the opposite of b, so that's negative 10 plus or minus the square root of 10 squared minus 4 times 1, which is a, times 21, which is c, all over 2 times 1, which is a. So m is equal to, now we need to take however many steps it takes you to come up with a single number for under the radical. So it's negative 10 plus or minus the square root of. 10 squared is 100. This is a negative times a positive, so it's going to be a minus 84 all over 2. So I have m is equal to negative 10 plus or minus the square root of 100 minus 84 is 16 all over 2. And now, and I guess you're getting used to me asking this question, once a radical creeps into the problem, you say, can I simplify it? The answer here is yes, because that is a perfect square. I have m is equal to negative 10 plus or minus the rational 4 over 2. Those are rational numbers, so I have negative 10 plus 4 over 2, and I have negative 10 minus 4 over 2. That's negative 6 over 2, or negative 3. That's an answer. I have negative 14 over 2, or negative 7, and that's an answer. It looks like this is a long process. It's just because I took time to show all of the steps. You're plugging numbers into a formula, you're doing the arithmetic, and coming up with two answers. These happen to be rational answers. All right, let's use the formula again. Try to get myself plenty of room. All right, I have x squared minus x minus 5 equals 0. That's in the right format. A is 1. B is negative 1. C is negative 5. All right, the formula, this time x equals negative b plus or minus the square root of b squared minus 4 times a times c over 2a. X is equal to negative b means the opposite of b. The opposite of negative 1 is positive 1, plus or minus negative 1 in parentheses squared minus 4 times 1, which is a, times negative 5, which is c, all over 2 times 1. You could simplify this all in one step, but I usually take 2 steps. I have 1 plus or minus the square root of. Negative 1 squared is 1. I have a negative 4 times a 1 times a negative 5, so that's going to make it plus 20, all over 2. So I have 1 plus or minus the square root of 21 over 2. Asking the question, can I simplify the radical? The answer is no. I cannot simplify the square root of 21, which means in my math lab, you would have 1 plus the square root of 21 over 2, and 1 minus the square root of 21 over 2. That's a little bit crooked, sorry. Just make sure you have the comma outside of the radical, outside of the fraction. 2 irrational answers for this one. All right, let's look at the next one. All right, in this one, I have A is an implied 1, B is 6, C is 13. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to, opposite of b is negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 13 all over 2 times 1. So x is equal to negative 6 plus or minus the square root of 6 squared is 36 minus 4 times 1 times 13, it's minus 52 all over 2. That gives me x is equal to negative 6 plus or minus the square root of negative 16 over 2. I'm sure you're expecting me to say it. Can you simplify? Yes, 16 is a positive, it is a perfect square, and it is a negative perfect square, so I get imaginary values. It's plus or minus 4i over 2. Because each of those numbers is divisible by 2, you need to reduce that fraction as negative 3 plus or minus 2i, and it would be over 1. We don't write over 1. So my answers in my math lab would be -3 plus 2i, comma, -3 minus 2i. Conjugate complex answers. We have a few more, trying to make sure that you see a lot of different scenarios. In this one, A is 1, B is -10, C is 25. So x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to opposite of b, that's going to be 10, plus or minus the square root of -10 squared minus 4 times 1 times 25 all over 2 times 1. So x is equal to 10 plus or minus the square root of -10 squared is 100, and when I multiply here I get minus 100 over 2. Well, sorry, that gives me x is equal to 10 plus or minus the square root of 0 over 2. The square root of 0 is 0. So that's gone, and I have only 10 over 2, or 5. I get one answer. It is sometimes called a repeated answer. X is 5. It's really 5 twice, but MathLab just wants it listed once. If you were to go back and look at this original problem, that's a perfect square trinomial. It's x minus 5 times x minus 5. So if x minus 5 is a factor, x equals 5 is an answer twice. Once again, MathLab only wants you to enter it one time. Okay, we have 2 more to look at. All right, in this one, A is 1, B is -1, C is -5. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. If you write it every time you use it, you will memorize the quadratic formula. X is equal to -b means opposite of b, so that's going to be +1, plus or minus the square root of -1 squared minus 4 times 1 times -5 all over 2 times 1. So x is equal to 1 plus or minus the square root of -1 squared is 1. This is a negative times a positive times a negative, so that'll be plus 20 all over 2. This is looking familiar. X is equal to 1 plus or minus the square root of 21 over 2. Can I simplify? The answer is no. So those are my 2 answers. 1 plus the square root of 21 over 2, and 1 minus the square root of 21 over 2. It seems very familiar. And that's because there it was. Was that the same problem? Yes, it was. I'm sorry I wasted your time on that. I don't know how it snuck in there twice. All right, the last one. This is a really good problem because this quadratic equation is not in this format. I need it to be in that format, and let me recommend that you have, it'll work either way, let the squared term be positive. So I have -4 is equal to 5x squared plus x. Because this is positive right here, I'm just going to add 4 to both sides, and I get positive 5x squared plus x plus 4. So A is 5, whoops, A is 5, B is 1, C is 4. And now let's use the formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to negative 1 plus or minus the square root of 1 squared minus 4 times 5 times 4 all over 2 times 5. So x is equal to negative 1 plus or minus the square root of, that's 1, and it's going to be minus 80 all over 10. Be careful with your signs. So I have x is equal to negative 1 plus or minus the square root of negative 79 over 10. Can you simplify that radical? You can a little bit. The square root of 79, the square root of negative 79 is I times the square root of 79, which cannot be simplified any further. So x is equal to negative 1 plus or minus I square root of 79 over 10. Two answers, negative 1 plus I square root of 79 over 10, and negative 1 minus I square root of 79 over 10. So, sorry that one of those examples was a repeat, but I hope this helps you using the quadratic formula.